Hello students, welcome to another algebra video. Welcome to the first algebra video on chapter 2. So our entry task looks a little bit different than normal. There's not a math problem per se, although technically it is. If I say I can eat no more than 8 pieces of French toast, how many pieces of French toast could I eat? I want you to pause the video and think about this. You can write out all of the options. Can you write this in a mathematical way? Pause the video, think about that, unpause it, and let's talk about it. If I could eat no more than 8 pieces of French toast, that means I could eat 8, right? I can't eat more than 8 pieces. No more than 8 pieces, but I could eat 8. But I could also eat 7, right? If I eat 7, that's not more than 8. Well, what about 6? That's not more than 8 either. 5, 4, 3, 2, 1. All of these are less than 8. In fact, even 0 is less than 8. So these are all the options. I could have no French toast. I could have 0 pieces. I could have 1 piece French toast, 2 piece French toast, etc. Now, it doesn't make sense to talk about negative numbers, because how could you eat -1 pieces of French toast? Let's not think about that. So these are all the options. A mathematical way of writing this would be that the number of pieces of French toast I could eat, n, let's call it, cannot be more than 8. So it needs to be less than or equal to 8 pieces of French toast. So this is the mathematical way of answering this question. Now, if you don't exactly know what this symbol means or what this statement says, that's okay. That's what we're going to learn about today and throughout all of chapter 2. So, let's get right into it. Section 2.1 is about writing and graphing inequalities. So our learning target is that you know what inequalities are and what their solutions look like. We know what a solution to an equation is, but what about an inequality? And the success criteria is that you can write inequalities and check their solutions. So you need to be able to do both of these things by the end of the video in order to know that you've mastered section 2.1, or the first half of section 2.1, that is. So let's move on to the vocab words. We talked about inequalities, but we need to know what an inequality is. So an inequality is a mathematical sentence that compares expressions. When we say compares, we mean things like less than, or, like we saw in the entry task, no more than. Things like that. So that's what we mean by compares. Some examples are right here for you. X minus 4 is less than -14. That's what that symbol means. And x plus 5 is greater than or equal to. That's what the line underneath the symbol means. Greater than or equal to -67. So those are examples, but don't worry, we're going to see many more as we go throughout this section. So now, it is very important that you know about all the symbols we're going to see in this chapter. So, these are the 4 symbols that we will be using. The reason they're called inequalities, right in the word, inequality, is unequal. If we just take away the itty at the end, you see it is unequal. So when we talk about inequalities, we're not talking about things that are equal. Instead, we're talking about things that are less than, that's what this symbol means, greater than, what this symbol means, less than or equal to. So notice this symbol is the exact same as the less than symbol, but it has a little bar underneath it. And the little bar means or equal to. It's kind of like the bottom half of an equal sign. Like that. Okay, so less than or equal to, and our last symbol is greater than or equal to, again, because it has that bar underneath it. So these are all of the symbols, and sometimes you might not hear these exact words, less than or equal to. Sometimes we say at most, or no more than, just like the entry task. I can eat no more than 8 pieces of French toast. So that's where the N was less than or equal to 8. That's where that came from the entry task, was no more than. So you might also see is at least, is no less than. You might see all of these things for these symbols. So if you want to pause the video and write down everything in this box, that is going to help you throughout this entire chapter. So if you're one of my students, you are writing this down. I require that you write it down in your notes. And if your teacher doesn't require it, I still strongly, strongly recommend that you write it down. Okay, let's use some of these symbols. Our first example wants us to write inequalities, writing inequalities. So, let's look at A here. A number W minus 3.5. Okay, so first off, what I get, I see W minus, so let's write that out, W minus 3.5. So we're just taking these words and we're putting them into math speak, into the math language. We are translating them from words into mathematical inequalities. So a number W minus 3.5 is less than or equal to. Less than or equal to. Remember, that's the symbol for less than or equal to, is this symbol right here. So is less than or equal to -2. Ta-da! That's it. That's it. We're just taking the words and we're translating it into an inequality. So, if you're like, oh yeah, okay, cool, got it, then pause the video and try B and C on your own. If you're like, nah, I need another example, that's okay. Keep watching with me. So let's look at B now. 3 is less than. 3 is less than a number n plus 5. N plus 5. Ta-da! 3 is less than a number n plus 5. So we just kind of breaking it down into pieces. I recommend at this time that you pause the video and try C by yourself, and then unpause the video, and let's do it together. 0 is greater than or equal to. Greater than or equal to twice a number x. So if I'm doing something twice, I'm doing it 2 times. So we're going to have 2 times x, twice a number x, 2 times a number x, plus 1. Ta-da! And there you have it. Nice and simple. 0 is greater than or equal to twice, that's where the 2x comes from, twice a number x plus 1. And there you have it. Okay, let's double check that we were right. W minus 3.5, yep. 3 less than n plus 5, and 0 greater than 2x plus 1. Awesome. Awesome. We were right. Okay, so another vocab word to start off our next example. Solution of an inequality. Now this is very similar to the solution of an equation. So the definition of a solution of an inequality is a value that makes the inequality true. So basically, you want a value. So if I have this inequality, x plus 3 greater than 9, the value of x, or a value of x that makes this inequality true is 2. Now, we're going to see an example of this in just a second. So, more important information. A solution of an inequality is a value that makes the inequality true. An inequality can have more than one solution. So remember, when we had equations, 2x plus 9 equals 6. Sure. When we had equations like this, there was only one solution. There was either x equals blank, we could have no solutions, or infinitely many solutions. But typically, we just had one solution, x equals something. But for an inequality, like we saw in the very entry task, when we had n was less than or equal to 8, I could have had 7 pieces of French toast. I could have had 6. I could have had 5. I could have had 1. I could have had 2.5. I could have had any number of pieces of French toast that was less than 8. So your inequalities can have more than one solution. So the set of all solutions, and a set is just like a collection of something. I have a set of dishes in my cupboard. I have a set of shampoo and conditioner that I use. A set is just a collection of objects. So in our case, a collection of numbers, like we had in the entry task. We had 1, 2, 3, all the way up to 8. That's a set. That is a set of numbers. Okay, so the set of all solutions of an inequality is called the solution set. So we're going to be dealing with solution sets today. So when you see this symbol, we have not talked about this symbol yet. A diagonal line through an inequality symbol means the inequality is not true. So for example, that symbol, this symbol right here, means is not greater than or equal to. Just like we had is not equal to. When you draw a line through something like that, it means not equal to, not equal to. Okay, alrighty, let's move on to our second example, checking solutions. So we want to know whether -4 is a solution to this inequality or to this inequality. Now, the way that we do that is we just have to check and see. So let's do A first. A, so x plus 8 is less than -3. So, is -4 a solution? Could x be -4? I don't know. Let's find out by making x -4. Let's make x -4, and then we can see if it's true or not. So I have -4 plus 8 is less than -3. Is that true? Well, let's see. -4 plus 8 is equal to +4, less than -3. Is that true? Is 4 less than -3? And if you need help trying to figure out, wait, less than, the wordage, if the wordage is confusing you, here's how I think about it. Here's our less than. We have 4, -3, that's what this case is. But here's how I remember. Whatever is on the small side, so you see there's a lot of space here between the top and the bottom of our inequality sign. There's a lot of space here. This is a big amount of space. And down here, there's no space. So this is how I think about it. We are big here, and we're getting smaller, 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 smaller. So whatever number is over here needs to be small, and the number over here needs to be big. So if I said, let's get rid of these lines there, that's confusing. If I said 0 and is less than 2, that is true because 0 is smaller than 2. So hopefully that'll help you, even if you see something like this. Now this is the small one and this is the big one. So it doesn't matter which way the sign faces. This might help you think about it. Okay, so now 4 is less than -3. If this were true, the smaller number would need to be over here and the bigger number would need to be over here. -3 is small. It's less than 0. +4 is bigger than 0. So this is not true. This is not true. Goodness, I'm trying to write a nice symbol here. This is not true. 4 is not less than -3. So we would say no, -4 is not a solution. And that's it. When it says tell whether -4 is a solution, you have to say yes or no. It is a solution or it is not a solution. And if you end up with something that is not true, 4 is not less than -3, then no, it's not a solution. Checking solutions to inequalities is a lot like when we checked solutions for equations. If you get something that is not true in the end, like we got, 18 equals 18, that is true, so our solution was correct. If we would have gotten like 16 equals 18, no, that's not right, so our solution was not correct. It's the same thing over here. Only we have inequality symbols instead of equal signs. Okay, let's change colors and let's do B. B says -4.5x is greater than -21. True? I don't know. Is -4 a solution to this? I don't know. Let's find out by making x -4. And remember, the parentheses means I'm multiplying these two things together. So, -4.5 times -4 is +18, and that's supposed to be greater than -21. Is that true? Yeah, 18 is positive and -21 is negative. Positive numbers are always greater than negative numbers. So, yes, -4 is a solution. Woohoo! Yay! All right. So let's see, our success criteria was that we can write inequalities and we can check their solutions. We wrote inequalities in the last example, and look right here, we checked solutions. So, oh good, we check our answer. 4 is not less than -3, so -4 is not a solution. -4 is a solution. Wonderful. Okay, so, did you meet the success criteria? Did you learn how to write inequalities and check their solutions? If you're still confused about any of those pieces, ask questions. Questions are wonderful. Questions are fantastic. Please ask them if you have them. It does not mean that you're dumb or not as smart as somebody else. I have questions all the time, and I ain't dumb. So, ask questions if you have them. Here are some practice problems. There are quite a few of them. If you want to try these practice problems, go for it. Remember that these might be different than the ones your teacher has assigned. So, try these if you want to, but remember, make sure that you do your assigned homework as well. Okay, and now, as usual, let's end with a launch. So, this comes from Camila Earing Kimball. Hope I pronounced that right. And it says, you do not find the happy life. You make it. Keywords here, you do not find. You do not find the happy life. You make it. And what that means is, you're not just going to stumble upon, oh, my life is happy. I'm happy. Everything is great. You don't just find that. You have to create it for yourself. This is something I did not understand in high school, and I was sad for a lot of high school because I was like, man, I'm not happy. Life isn't happy. I don't have a ton of friends, and people don't miss me when I'm gone. Like, it wouldn't make a difference if I were here or not. That is the wrong mindset to have. I was trying to find the happy life instead of taking it into my own hands and going, you know what, I'm gonna make friends. I'm gonna invite friends to hang out with me. Instead of waiting for somebody to ask me to hang out with them, I'm gonna ask somebody to hang out with me. I'm gonna make my life happy. I'm gonna find things that bring me joy. I'm gonna start a hobby. I'm gonna start writing. I'm gonna start singing. I'm gonna do whatever it is that makes me happy. Because if you just sit around and wait to find the happy life, you might not find it. And then you're just sad. And nobody wants to be sad. So, make the happy life for yourself. Make yourself happy. And then, yeah, you can have a happier life. So, that is my launch for you. Take it with you as you go throughout your day. Have a wonderful rest of your day. And thanks for being here. Thanks for watching. Bye.